Okay, from the second one, this one is a chemical cell. Chemical cell means we're using the chemical after that to produce the electricity. So you can see the diagram. They're just using the potato. Okay, using the potato. After that, they join the metal. Then after that, they join the bulb. So finally, the bulb can be light up. So that means we're using the chemical things can produce the electricity. Okay, now we go through this part. Okay, you can see the diagram. They almost same like what we learned before for electrolysis. But the problem is we're never using battery. You can using the put voltmeter only. So that means later if got current pass through the circuit, the voltmeter will be deflected. Okay, voltmeter deflected means we understood that they got current pass through the whole circuit. Okay, now we're still using the electrode. Okay, now the electrode one is called magnesium. Another one is a copper. Okay, then we still got electrolyte. Electrolyte now is a copper 2 sulfate solutions. Okay, now you will ask about electrode. Why magnesium must put at the negative? Why the copper will put at the positive? Okay, so this one later we need to discuss how we go to choose which one terminal you need to join which one for the electrode. Okay, let's see here. At a simple chemical cell, is made up of the two different metal. So they emerge into the electrolyte. So emerge into the electrolyte and also connected to the external circuit. This one we call external circuit, the outside one, with connecting wire. Okay, so this one is how they go to build the simple chemical cell. Okay, positive terminal and negative terminal for the electrode are determined according to the electrochemical series. Still remember this one, chemical series? Okay, we follow by the, okay, yesterday could call you to memorize. So that one is start from the P, is it? P stand for please. Please stop calling me careless zebra. Okay, so the stop 5 you must remember. Please is potassium. Stop is sodium lah. Call is calcium. Then call me is a magnesium. Then please stop call me careless. Careless is a careless is what? Aluminium. So the top 5 you must remember. Potassium, sodium, then calcium, then magnesium, then aluminium. Then after aluminium, they got one of the block. That one the block is a carbon. Carbon is blocked at the between zinc. Okay. After carbon should be the zinc. Zinc is a zebra lah. Zebra after that they say instead. Instead is an iron. Okay. Instead to calling me. Instead try. Instead iron. After try is a tin. Instead try learning. Learning is a lab. Okay. Learning. Then copper safe go. Okay, after lead, there's a copper, then safe is a silver. Okay, you got one is a hydrogen at the middle. Okay, so that means carbon and hydrogen is stopping insert into the middle. So that means the carbon is at the top, then the hydrogen is at the bottom. So hydrogen is in front to the silver and also the gold. Okay, so remember the arrangement for this one's chemical cell, we need to know the top 5. Okay, the top 5 sure is a more reactive one. The bottom one, copper, then after that the silver and also the gold, that one sure is a not reactive one. They're at the bottom. So from here, this one, which one electrode we need to choose? We need to depend for the electrochemical series. So now we how to choose. Okay, let's see here. Negative terminal. Okay, negative terminal, we need to choose is more electropositive, means more reactive. Okay, so from here, copper and magnesium, sure magnesium is a more reactive. So we choose terminal negative is a magnesium. Okay, then after that, the positive one we choose is a less electropositive. That means the bottom one. Okay, so we got reason why we need to choose like this. Okay, so remember the first step when you want to set up about a chemical cell, the more electropositive one, more reactive one, we put at the negative terminal. Okay, then the less reactive one we put at the positive terminal. Okay, then after that, we both also immerse into the electrolyte. Okay, so from here, the outside one, this one we call external circuit. External circuit we join with the voltmeter. Okay, so the solution depends for use lah. We need to using normally the same like the one of the copper. Okay, same like the one of the, you see here is using copper too. So that means one of the electrolyte and also the electrode, the material must be the same. Okay, so from here we go to see how to choose the electrolyte and also the electrode. So normally if you're using the copper, the electrode, you must choose the thing same like the terminal positive electrode. Okay, same like the terminal positive electrode. So if I'm using silver, so that means your solution must change become silver. Okay, we never follow the negative electrode. Okay, we follow the positive electrode. So that means we follow the lowest one, the low reactive one. Okay, so from here we're going to see this one is arrangement. Okay, potassium, sodium, calcium, magnesium, aluminium. So we stop at the aluminium. So this one is the top 5 more reactive. Okay, please stop call me careless. Careless is a carbon. Okay, then after that zebra is a zinc lah. Okay, then after that instead is an iron. Then after that instead to learning. After that we got hydrogen. Learning how copper safe. After the last one we got gold. Okay, gold is the last one. So from here normally more reactive is the top 5 only. After the carbon, zinc and iron become less already. Okay, the bottom one, copper and silver, sure is the neutral one. That's a natural one. So that means you want to make it electroplating, normally using copper and silver lah, electroplating, because they want to produce the ion. After that, the stick one, they make it become more thicker. So from here, the lowest one is a less electropositive, highest one is a more electropositive. So negative terminal magnesium is it? We choose magnesium because magnesium is a more reactive than the top. Then they will donate electron. So remember, when you choose that one is at the negative terminal, first one, they must very, very strong electropositive. Okay. Number 2, if they're very strong electropositive means they can donate electron. Okay, they can donate electron. So from here, the positive terminal sure is a copper. Copper is a less electropositive. Okay, so this one is how we go to choose for the simple chemical cell. More reactive at the negative terminal. Less reactive, we go to the positive terminal. Okay, then the more reactive, sure they will donate the electron. Okay, now we go and see the donate electron go where. Okay, this one is a copper. Okay, we choose magnesium. Okay, so the first one, okay, we go to focus to the magnesium. Okay, magnesium now they will donate the electron from the magnesium ions and dissolve into the electrolyte. So the electron, when they just come out, they go in the solutions. Okay, they will go in the copper 2 sulfate solutions. Okay, then after that, continue. Magnesium act as a negative terminal. Okay, magnesium now is a negative terminal. Okay, the released electron. Just now they release the electron to the electrolyte, is it? So that means when the electron just start to moving, that means you got current already. Electron start to go means you got current, but the current is opposite direction with the electron. So they say the released electron will flow through the external circuit. So just now the electron, you go to the solutions. So that means the electron will go up to the circuit. Okay, will go up to the circuit. So from here, they say they flow through the external circuit from magnesium, go to the copper. Okay, electrons start to flow from magnesium, go up, pass through the voltmeter, then go to the copper. Okay, now the copper is what? Copper is a positive terminal. Okay, so electrons start to move, pass through voltmeter, go through copper means what? Means already got current. Agree or not? Because electrons start to move already. So that means the current, they will pass opposite direction. The current will start from the positive, go to the negative. Electron never move, no current. Electron start to move, that means the circuit will on already. So that means what happened? The voltmeter reading will be deflected. Okay, when it just deflected, then we need to read how many volt, then we know the whole circuit already got current. If you put the bulb will be light up. Okay, so this one is a chemical cell. Okay, now you can see the direction for the electron. They start to move. Okay, electron is moved from the magnesium, go to the copper. Okay, electron from the magnesium are received by the copper to ion from the electron. Okay, electrolyte. At the bottom, electron, they will go up, is it? Okay. Inside the solution, they still got electron. Then the electron go where? They can, through the liquid here, go to the copper. Okay, up, they got electron. Down also got electron. Then the electron ion in the solution, they also go to the copper. So what do you think about the copper? Copper will become thicker and thicker because all the electrons go there. So magnesium, how? Magnesium become thinner and thinner. Okay, so from here, the conclusion is, the diagram you can see like this already. Okay, now the electron flow. Okay, then after that, the electron inside the solution, they also will go to the copper. So you can find the copper become thicker. Then the magnesium become thinner. So from here, we can make a conclusion. The flow of electron from the negative terminal to the positive terminal through the external circuit will produce electrical energy. Okay, when it just go from negative up, go to positive. So they can produce the electrical energy. So that's why the voltmeter can be deflected. Okay, at the bottom, how? At the bottom, you see the copper become thicker. When it become thicker, mean the mass increasing. Okay, then the magnesium, the mass decreases. Okay, now the question will ask, what energy transfer now? Okay, now we need to see the energy transfer is from the chemical, go to the electrical. Okay, so this one we call chemical cell. Okay, important, you go to choose which one should be negative terminal. How to choose? Refer to the electrochemical series. More reactive, that one sure is a negative terminal. Okay, then you go to explain about electron donate lah. Okay, the negative electron, they will donate the electron. When they donate the electron, they will go into the solutions. Okay, after that, the electron also will go up to the external circuit. Then the external circuit got electron to move, that means the current will start to go. So at the bottom, the electron ion, where they go, they also go to find the positive terminal. So finally, what is the result? Result, external got current. Okay, electrical energy produced. At the bottom, the ion will go to the copper. So you see the copper more thicker. Then the magnesium become thinner. So this one is up and down also got changes. Okay, we see example 1. Okay, you can see first diagram. You can see this one is a zinc. Okay, this one is a copper. Now you go to think about that. Arrangement for the electrochemical series. Zinc first or copper first? Okay, anybody can tell me? Zinc at the top or copper at the top? Okay, Tiala, they told me there's a zinc. Okay, Leong Yuqing also says zinc. Zinc first, copper is the bottom. So zinc become negative terminal, agree? So the copper is a positive terminal. So from here, zinc will donate the electron. Agree? So from here, you can find here, this one using galvanometer. Galvanometer also one of the things to test got current or no current. They just want to testing only. They don't want to read. Okay, so from here, the tips, number 1, you need to know electron flow from negative terminal to positive terminal. Negative, the electron must start from the negative, go positive. Okay, so from here, we need to show about the question. Okay, this one is one of the questions. So from here, based on a simple chemical cell, we determine the positive terminal. So everybody know lah, here they already label. So the positive terminal sure is a copper. Okay, copper. Negative terminal should be the zinc lah. Okay. Number 3, direction of the electron to flow. Electron how to flow? They must from the zinc go to the copper. Okay, because electron from the negative go positive. So from here they start move, they go to the copper. So we just answer from the zinc to the copper. Okay, then changes mass. Okay, changes the mass. Which one become heavier? Okay, which one mass is higher, zinc or copper? Answer, copper. Okay, copper is more mass because just now donate electron, then the electron that will dissipated to the copper, then the copper become thicker. Okay, so the final answer is mass of the copper increases while the mass of the zinc decreases. Okay, this one is a one sample question. Okay, so this one is this one is a current, current flow. You can see the red color is a current flow. They start from the positive, then go to negative. Okay, electron is terbalik. From the negative, go to positive. Okay, now we go to second question. We got magnesium, we got zinc. Okay, which one should be more electropositive? Which one is more electropositive? Magnesium or zinc? Okay, electropositive means more reactive. Which one is more reactive? Okay, magnesium is more reactive because magnesium is the top 5. Okay, zinc is the bottom 1. So that means we choose the magnesium become negative terminal. Okay, so from here positive is a zinc. Negative is a magnesium. Okay, direction. Current, the electron how to flow? The electron must start from the magnesium, go to the zinc. Okay, if the question asks how the current flow, you must terbalik. Current start from the zinc, go to the magnesium. Okay, so we just answer for the electron, magnesium to the zinc. Okay, changes of the mass also same. The zinc will become mass higher because it become thicker already. So the magnesium become thinner. So the mass is zinc increase, magnesium decreases. Okay, so this one is what differences when the chemical cell happen. Okay, this one is current how to flow. Current from the zinc go to magnesium. Okay, we see the application for the chemical cell concept in the generating electrical energy. Okay, this one is an example. You can try. In your house, if you've got the wire connection, that means you can try using the lemon. Okay, you must have the plate. This one is a metal plate. So metal plate can conduct electricity. So from here, the food such as a lemon, they can be used to generate the electricity. So like this one diagram means what? Chemical energy from the lemon, okay, convert to the electrical. Okay, so now this one should be the last one because we want to see the chemical for the concept. From the food also can. Okay, so from here, some veggie also can. Example, they can using potato. Okay, this one you can try a potato. I mean, your house also got lah, but the problem maybe you don't have the wiring. Okay, the wiring, they just put the nail. Okay, put the screw, they just put in. After that, they join with the wire, then to the bulb. Okay, a bottom bulb must be joined tightly. They're using the hot glue gun. Okay, hot glue gun to stick the wire at the bottom. Okay, after that, you will find it when starting, they are slowly first. You can see the light is very dim. Slowly, they become brighter. Okay, because all the positive and negative, they can go up already, the ions. So the easy starting, they must slow because they never accept anything. Then you must slow. Then after that, the ions start to moving already. Okay, they become brighter. Okay, this one you can try by yourself. Not just only for lemon. The orange, something about got acid, they can function. Okay, orange also can. Okay, you can try any vegetable or any fruits that can conduct electricity. Okay, but this one electricity sure is very small lah. You cannot say you're using it to charge your phone. No, they're just only very small current. Okay, so we just finished the 6.2. So this one is the first exercise you need to do for the yesterday, 6.1, and also the others exercise. Hopefully you are finished. Okay. Okay, so from here we see the formative practice 6.2. Okay, what is a simple chemical cell? So you must say the simple chemical cell, they must from the chemical convert to the electrical. So we're going to see the simple chemical cell. Okay, simple chemical cell is a device. We convert chemical energy to the electrical energy. So this one we call chemical cell. Okay, number 2, you need to draw. Okay, you need to draw and label the simple chemical cell. Okay, this one is a exercise. So you need to draw. So that means you don't have battery. Don't draw the battery. We just draw got voltmeter or galvanometer or bulb also can. Okay, so now I go to show. Okay, the diagram exactly same like just now. Okay, the two different of the method depend for you lah. You want to label what metal also can. Okay, important, the big difference for the electropositive. Okay, you can using copper, you can using zinc, then another one should be higher a bit for the electropositive. Okay, I got one of the question. If two plate I also using same material, example, magnesium. Okay, you tell me got any current or not? If two also is the same material, no current flow, because we cannot choose one. The electron you want to produce, both also produce electron, then go where? Do not go where. Okay, both also cannot receive. Okay, so remember, must have different. If the big different, example, potassium and also zinc, you can see the gap. The gap is very far. From the potassium is the first one, then the zinc is the bottom one. The gap is bigger, means you produce the electron is more. The current is higher. If the gap is smaller, example, aluminium and also zinc are very small only. Okay, so they also can produce, but very, very less. Okay, so you must depend the gap. Okay, how far the gap. If the gap is the same, magnesium, don't have any electron to produce. Okay, so that means the the voltmeter cannot show any readings. Okay, so that one is level electropositive. Okay, number 3. How does the position of an ion in the electrochemical series determine the positive terminal and negative terminal? Okay, so positive, we normally don't talking. We just talking about the negative important. Negative, we choose more electropositive one. Okay, so the rest one we choose less electropositive. So from here in the simple chemical cell, a metal with position higher in the electron series. Higher means electropositive is higher lah. They act as a negative terminal. Okay, while the metal with position is lower in the electron series, so that one will become the positive terminal. So important, you need to know the negative terminal must be higher level. Then after that, the positive terminal is the lowest level. So this one is how we go to set about the electron. Okay, only 3 questions for 6.2 you need to do. Okay, now I will show some exercise. Please, I call your name, then you answer me. Okay, we're going to see question number 1. Okay, now they say which one metal can be extract from its ore only by the process electrolysis. Only for electrolysis. Remember, the ore is the first process, extractions. So extractions may mean they choose the more reactive material. Remember, top 5. The top 5 should be the magnesium, because you see the tin, you see the copper, the lead is the bottom one. So extraction, we need to choose the more reactive one for the electrolysis. So the top 5 must be chosen. Okay, question number 2. If the voltmeter needle does not deflected, you tell me what is the P. Okay. Okay, the answer C. Why? Because no electron pass through the circuit, means both electrode must be the same. So that's why they cannot drop the electron. Electron drop also do not go where. So must be same material. Only this one situation you can get the answer straightforward. Both also is the same material. So the answer is C. Both also is a copper. Okay, then we go to number 3. Number 3, they show about electrolysis for the electrode plate. Okay, electrode plate for the nail. So they ask you, what is the metal X? Okay, what is the metal X? Okay, the tips, we need to refer to the solutions. Need to refer to the solutions. Okay, now the solution is what? There's a nitrate, this one, silver nitrate solution. Silver. So you tell me what should be the X. Okay, we go to choose is Ivan Fong.
Yeah. A.
A. Okay, so the answer is A, because you want to electroplating. Okay, electroplating means you want to make the nail become the color same like the metal X. So the metal X, you want to let the electron, the ion to come out. So the electrolysis must be same material. So you see the metal X is a silver, then match with the electrolyte. Electrolyte also silver. So later your nail also got silver color lah. So from the answer is a silver. Okay, number 4, they ask which one following are X and also solution P. Okay, X and solution P. So this one is a purification. Remember, impure is at the anode, pure at the This one is a anode, is a pure. Then the cathode is a impure. So they ask you which one should be the X, which one should be the P. X, you know lah. X, you see this one longest one, the battery longest one, sure is a positive one. Okay, then what is the P? Okay, so number 4, the answer is anode lah. You see this one, the positive terminal. So sure X is an anode. Then after that you see both also is copper, pure copper. This one impure copper. So your solution must be copper lah, is it? So from here must be copper to sulfate. So the answer is C. Okay, then we go to the number 4. Okay, which of the following are X and also P? Same question. We continue for number 5. Okay, what will happen to the anode? Okay, anode is what? Anode is impure. What happened for the impure copper? Impure, later they will give all the copper, go to the pure. The pure become thicker one. Okay, so the impure must become thinner. Okay, so we go to the next. Number 6. Okay, number 6, which one is a following process can be used to prevent rusting? Rusting, we're using what process? Okay, we're using electroplating. Okay, correct. Okay, 7. Okay, 7 is what is the metal extracts using electrolysis? Extractions again, extraction. Top 5, more reactive. Now you choose for me which one is the top 5. So the answer should be C. Yeah, correct, Kaling. Okay, calcium, aluminum, and the sodium. That one is the top 5. So they're using for the extraction for the electrolysis. Okay, then we go to the structure already, sir. Okay, structure, you can see this one diagram is a chemical cell because they're using voltmeter only. So first one, what can be observed on the voltmeter? Okay, the voltmeter sure got deflected lah. For this one situation, you can see one using zinc and another one using copper. Still got a little bit gap. Although both also is a weak one. Zinc is the bottom, copper lagi bottom, but they still got a gap. So that means they still can conduct electricity. So the voltmeter pointer can be deflected. Okay, what's inference we can do for the number 1A? Okay, deflected actually means what? Deflected means the current produced. Okay, for the circuit. Okay, can you write the energy transformation that occur in this one experiment?
Okay, chemical to electrical.
Okay, chemical to electrical energy. Okay, then we go to the D. What will happen if the copper plate replaced by the carbon rod? Okay, now you see carbon. Carbon, where's the carbon? Carbon is in front, the zinc. Okay, that means they still got a gap. carbon and also zinc, they still got a gate. So they ask you what happened if I don't using copper, if I using the carbon rod. Actually, there's no changes. They still got deflect, but the deflect is very small lah. The pointer of the voltmeter is still deflected. Okay, give the reason. The reason is the carbon rod also can conduct electric current. Okay, they also can conduct electric current unless you go to use the insulator. If you're using the wood, nothing happen lah, because the wood also cannot conduct electricity. Okay, so the last one, you give me the example for the food that can be used to replace the vinegar solutions. Okay, we don't want using vinegar solution, we can using what? Lemon. Yeah, we can using the lemon juice. Okay, so from here, either you say pineapple juice, orange juice, or lemon juice also can. This also can conduct the electricity. They're just like the electrolyte. Okay, so this one is what I want to perform. Okay, we are until 9 o'clock. Okay, so today lesson just until here.